Today I wanted to talk about creating a backend API using Express and TypeScript. We're going to create a brand new Node.js application and integrate TypeScript and Express. Our API will be very simple. It'll just manage a list of to-do items for us. The first thing we need to do is to initialize an application using npm init. This will create a basic package.json file for us to get started. Then we'll install our dependencies including Express, CORS, and Body Parser. Next, we'll install our dev dependency including TypeScript as well as the typings for Node.js. The last piece of the puzzle is to set up our project to compile our TypeScript files into JavaScript. First, we'll need to install TypeScript globally. Once TypeScript is installed globally, we can run the tsc-init command, which will create a tsconfig file. This file will tell the compiler how we'd like our code compiled. We can remove most everything from this file since we're not going to need the majority of it. We're basically just going to add an out directory so our code compiles into the dist directory, and under compiler options we'll add the include array so that the compiler only looks at our source directory for the code. The last thing we're going to do is add a start script to our package.json to make running our app a little easier. Let's start coding. The first thing we'll do is import Express, Body Parser, and CORS. Then we'll create a new Express app and make sure to use CORS and Body Parser. These allow our API to be used on front-end applications as well as ensuring that it can receive JSON objects. Lastly, we'll make sure our app is listening on port 3000. Now that we have a basic template, we can add a test route. This will just return a hello world response so we can ensure that our app works. There are lots of different REST clients available to you, but for this demo, I'll be using Insomnia. Let's make a GET request to our API and make sure we get our hello world response. Now that we know our app works, let's start making use of TypeScript. We can use TypeScript to create a to-do item model. This describes what a to-do item is. We can use our new model by creating an empty array of to-do items. This will manage all the to-do items for our API. Let's create two new routes. One that will return the list of to-do items, and the other will add items to our array. Our get method is pretty simple. We just return a 200 response with the full array of items. Our post request gets a little more complex. Since we're adding new items, we want to check the request body. If we don't have one, we'll return a 400 error. Then we'll turn the JSON object of the body into a to-do item. We can also check to ensure that if the item is not given ID, that we can assign a random number to the ID. The last thing we'll do is push that new item to the array and return a 200 with the full array of items. We can open Insomnia and test our new routes. Let's post a new item first. We'll define the title, description, and if it's done or not. Then we can send it to the API. We can see that it returns the full array of items. Then we can make sure that our GET request is returning that same array. Now what if we want to return a specific item from the array? Let's create a new endpoint using a router parameter. We can grab the router param using the request parameters and then use that ID to find a specific item in that array. Let's pre-populate our array with a few items that we can play with later on. We'll make the same GET request so that we can see the full array of items. Then we'll copy the ID from item 2 and make a new GET request where we fill in the ID of the router parameter with the ID we want to look up. If we fill in the router param with an ID that doesn't exist, we'll see that we get our 404 not found response. Another common endpoint we might want is one that allows us to update a single item. To do this, we'll create a new put request using another router parameter for the ID. We'll do the same checks to ensure that the item exists, and then we'll check for each field before applying the update. The last thing we do is return the full list of items. We can go back to Insomnia and create a new put request. We'll request to update item number 2 and set the done property to true. Once we make the request, we can see that it did in fact update item number 2 to done. The last thing we might want to do is to be able to delete items from the list. We can add a simple delete request using a router parameter to grab the ID. We'll do our usual checks before removing the item from the array and returning the full list of items. Let's test this in Insomnia by deleting item number 2 and making sure we get the correct response back. That's all for today. I hope you learned something from this video, and if you did, make sure to like and subscribe. See you next time.